So first one, you can see this type of compound. Now see carefully, there are two bridged carbon atoms. This is 1 and this is 4, because there are two bridged carbon atoms, and these two bridged carbon are connected with the help of a methylene unit. You can see here the carbon is present. I hope you can see this is another carbon which connects these two ends and playing the role of a bridge. Okay, so these are two bridged center. Now you can start numbering either from left side or right side, because there are both have symmetrical, that is, in left side two carbon atom present between 1 and 4th position, where 1 and 4th carbon atoms are bridged center, right? So between 1 and 4 there are two carbon atoms present in left side as well as in right side. So you can choose any one of them, both are correct, but you cannot choose from top side, because the top one has only one carbon atom between these two bridged center. So you cannot go along the top side. You need to numbering either from right side or left side, because according to the second rule, here you can see the higher number of carbon atoms should be present between the two bridged center. Here the higher number of carbon atoms, 2 is greater than 1, hence you can choose either right side or left side in order to start numbering for this compound, right? So I have started numbering from right side. You guys can started numbering from left side as well, no issue about that. So 1 2 3 4 5 6 carbon atoms, and the residual carbon present here, which is 7, right? So here I have written the bicyclo, because it is a bicyclic compound. For every bicyclic compound you need to write the bicyclo word until and unless it has a substituent. Here I have shown you that every compound contain no substituent within it. If there is any substituent, then I will told you then what should be done. Okay, so first you need to write, in this case, bicyclo whenever the compound is devoid of substituent. So for every bicyclic compound you need to write this name bicyclo and open the square bracket and write 2.2.1. that is, here 2 means these two carbon atoms which present between these two bridged position. Okay, so here 2 2 1, and these 3 digits are present, and you need to insert the dot. This dot is very important. You cannot use any other symbol. You need to use this dot. Okay, so 2.2.1, and it is decreasing order. Alright, it is a decreasing order, which the third rule say that always follow the descending order. So 2 is higher than 1, hence you need to write 2, again 2, and this 1, because here 2 carbon atom present in the left side, also here 2 carbon atom present in the right side, and the residual carbon atom present at the top side, hence I have written it at the end. Close the square bracket and write, count the total number of carbon atoms. 7 carbon atoms present into this compound, hence heptane, and all are sp3 hybridized. Okay, saturated ring, no double bond, no triple bond present in this case. So here you can write heptane. So this is bicyclo, square bracket, start 2 to 1, close the square bracket and count the total atoms. 7 carbon atoms, hence heptane. So in this way you can do the numbering. Another example here I have shown you to clear these things more, and here I have drawn another compound. So here again this is unsymmetrical, right? Because there are different number of carbon atom between these two bridged center. Here bridged centers is 1 and 5th. These two carbon connected by a carbon which I have numbered 8. So 1 and 5th are bridged centers, and in left side there are 3 carbon atoms. Here, as I hope you can see, there are 3 number of carbon atom in the left side. In the right side there are 2 carbon atoms, but in the top side there is only 1 carbon atom. So Bicyclo as usual, since no substituent present in this case, so you need to write the bicyclo. Start the bicyclo, square bracket open, 3 2 1, because 3 higher than 2, 2 higher than 1. So according to this 3 2 1, total number of carbon is 8, so octane. So bicyclo 3 2 1, close the square bracket and write total number of carbon atoms octane, since there are 8 number of carbon atoms. Okay, so this is octane. So in this way you can numbering you can do the nomenclature for any bicyclic compound. Another example, just here again 1 and 5th are two Bridget center, but there are no carbon atoms in this case. 1 or 5th are two Bridget center, okay, left side 3 and right side 2, and here no carbon atoms is connected. The 1 and 5th center directly connected via sigma bond with each other, and in the previous case there are one carbon atom at least present at the top portion, okay, but here this situation is not present. Here 1 and 5th are connected via sigma bond, and in the left side there are 3 carbon atoms. You can see 2 3 4 3 carbon atoms. This is only 2 carbon atoms present between the 1 and 5th. So you need to consider the left side, not the right side, okay, because left side has higher number of atoms between the Bridget center, while right side has lesser number of carbon between the Bridget center. Thus in this way you need to do bicyclo within the square bracket 3 2 0. Why 0? Since there are no atoms present between 1 and 5th, okay, 1 and 5th carbon connected directly with each other, so here I have written 0. So this is also you should notice, right? And total number of carbon 7, so heptane. Let's do another example. Here again 1 and 6 are two Bridget center. Always you need to distinguish the Bridget carbon atom. In this case, whenever you do the nomenclature for any bicyclic compound, you need to distinguish the Bridget center. Always you need to distinguish the Bridget center and count the number of carbon atom between these Bridget centers in both left side, right side and top side. You need to notice that the side which contain higher number of atoms between the Bridget center will give your first priority, and from that side you need to start your numbering. Okay, so this is your approach. So let's do this one. 1 and 6 are Bridget center. Left side contain 4 carbon atoms, but right side contain 3 carbon atoms. 4 is higher than 3 like the previous case. 1 and 6 are directly connected with each other via sigma bond. There are no atoms present between 1 and 6. 1 and 6, these are two Bridget center, but these are connected via sigma bond. There are no carbon atom present between them. The carbon atoms present at the left side and right side only. Left side has higher number of carbon atom than that of right side, because there are 4 carbon atoms present between 1 and 6th position, while in right side there are only 3 carbon atoms present between 1 and 6th position. It is bicyclo 430 non-N. 430 is the descending order. 4 higher than 3, 3 higher than 0, and it should be written within the square bracket. Okay. Now let's do about this. What about this? You should know such type of compound. This is decalene or parhydronaphthalene. Okay. So again 1 and 6 are Bridget position. Here this is symmetrical compound. Both left side and right side possess similar number of carbon atom, 4. Here also 4, here also 4. So don't worry about that. You can start numbering either from right side or left side, because the compound is symmetrical, possess equal number of carbon atom between the two Bridget center. Okay, so you can numbering from left side or you can numbering from right side. I have started numbering from right side here. So 1 2 3 4 5 6 7 8 9 10. Bicyclo 440 Deccan, 4 number of carbon atom present between 1 and 6th. Again 4 number of carbon atom present between 1 and 6th at both left and right side. Okay, equal number of carbon atom. Hence 4 4s and 0 y0, 1 and 6 directly connected with each other with the help of single bond. There are no carbon atom present between this 1 and 6th position. Okay, hence I have written 0. Total number of carbon 10, thus Deccan.